I'm proud to be a nerd. I don't know if I define myself as a nerd. I mean, I kind of know I am, but whatever.
Basically, I was a nerd from the very beginning because I decided I like math and science.
That's why we're called Nerd Girls. It's fun to work with all girls for once. It's a male-dominated profession, and
I definitely think that girls can compete in a world that is male-dominated. There's really no difference. Maybe the girls are a little more friendly with each other.
You meet someone and you're like, oh, you're a woman in engineering, and da-da-da, and you have this like instant bond, and it's really great.
We have friends outside of engineering and just aren't going through the same problem sets and stresses that we do, and so it's nice to come to an organization or group like Nerd Girls and feel like everyone's sharing your pain.
There are 6 seniors working on the solar car team. 3 are mechanicals and 3 are electricals. And there's also 1 junior electrical engineer. And some other juniors are starting to join the group to kind of carry on the torch when we all leave.
And we kind of split it up for the mechanical team with the frame and the shell and the motor. Joanna's doing a lot of the motor stuff.
It was a project that I saw when I came to Tufts, actually, when I was looking at different schools, and just something that I was really interested in. I was really interested in the solar power aspect of it.
And who doesn't want to build a car in their time as an undergrad? I mean, that's really neat to say, oh, I worked on the whole electrical system of a solar car. It's always a good conversation starter, especially in interviews.
The rule number 1, when everybody comes on the team, the first thing we talk about is safety and OSHA and things like that. Notice all the controls are over here.
way over here though?
Yeah, but can you imagine going 70 miles an hour?
If I go to hit the horn.
Yeah, you're gonna get killed. Can you see behind you?
Yes.
You can?
Well, if I turn around.
Now, there's your ventilation right there, and it's connected to the battery box. So batteries give off some sort of chemical. Essentially, unless you have some sort of external fan blowing it out, it's only the wind resistance from the car that's going to suck the air out. If you notice, the motor is this way, and the chain is supposed to be at a 90-degree angle, perpendicular to it. So the motor was an afterthought. They built the frame, and they were like, oh, okay, we got to put the motor in. So they angled the motor in, and the motor is kind of off-center, and then so that you can't get a nice 90-degree angle here. Mistakes other people make is probably the best learning tool you could ever have. You can see the chains actually hitting the frame. So when we're riding, and then if you go over a pothole, the whole thing plops off.
We did a lot of research individually online and said, okay, well, what is this piece and why do we attach it here and how do we make it so that we can buy that? Where do we buy it from? So definitely for us, I think system engineering diagram was where we started. We talked to a group of human factor engineers to help us plan out the cockpit, and so we had them help us lay out things that were ergonomic for the human body, the female body, and we used myself and Christine as extremes. So I was obviously the taller, larger extreme, and she was the shorter, smaller extreme, and it helped because we have a wide variety of sizes of females that are going to potentially be in this. And so it was cool because they gave us dimensions and a whole system, a way for us to plan out the seat and the dashboard and the layout of everything.
I work on an FPGA, which is a field programmable gate array.
This right here is the FPGA.
If you're in a car, this little controller is going to take information from all sorts of sensors in the car, and it's going to tell you the speed of the car, any faults that are occurring in the system, and any other information you might need on a normal dashboard in a car. The computer does a lot of the work, so I'm synthesizing my code right now, so it's taking all the stuff I wrote and breaking it down and basically mapping it to all of the hardware that's inside of that little FPGA. And basically just plug it in. It's like using a USB key memory stick or plugging your iPod in and putting songs on it. The solar cells for our new car. They're the best we could do with the highest efficiency. Efficiency means how much of the sun's light is actually harnessed as energy. Everybody thinks that the car runs off of these. They don't. They actually charge the batteries. So these charge the batteries and the car runs off the batteries.
There's 2 battery banks on either side with 7 batteries, and they're going to go on either side of the driver so that they can be accessed easily when you just take off the hood for the driver. They're going to be made out of carbon fiber in addition to the frame because it's thinner and it should support all that weight. Yeah, so this was the first roll cage and the battery configuration.
I knew the roll cage had to get changed.
Yeah.
My car's still square.
Of course it's still square.
Car's not square.
Well, why is it not rounded in the front?
Trust us. We're engineers.
I know, but it's ugly. All right.
No, it's not all the cars. Oh, like, you
Oh,
see
wait,
a lot of the
but I
cars.
wrote down here.
They are square. They're not rounded around the front. Because you lose surface area, and you want to put as
So
much
you're
cells
putting
as possible.
you're putting solar panels in the front of this as well?
Yes,
The whole
they,
car is getting covered in solar panels. Otherwise, it's not gonna. It's
it's
gonna
a
be way
waste.
too long.
Yeah.
Well, I mean, how far do the solar panels go?
Well, on this
I mean,
car,
the-
you can't actually fit them. That was the problem I was having.
Wait, I'm confused now.
But in general, you're gonna have them on the front, you're gonna have them on the side, and you're gonna have them on the back.
Well, I'm looking at this angled thing. I mean, am I cutting my panels?
No.
No.
What I wanted to do was get rid of those lines there and kind of maybe like smooth out and kind of flatten out the whole thing
Okay.
together. So we were gonna do that in the molding process with James.
If you've only got one motor and it fails, you're out of the race. So what we're doing, the design we have is actually what we call fault tolerant, and we're going to have redundant motors so that we'll have two motors going and we'll be able to charge the batteries, different banks of batteries at different times. And if one motor goes down, we can go to the other one.
We did a power balance, and from that, we determined that we needed a certain torque and certain amount of velocity or RPMs for the motor. So this is a Perm 132 motor right here. It can run up 3,500 RPMs. The car's going to be running about 60-65 miles per hour. So this is going to have a gear ratio of 1:3. So this is 3 times 60, so about 180 RPMs max.
I came to Tufts just as a general engineer because I was good at math and science. I didn't have a lot of computer experience. And when I got here, I just took classes in computers and in electrical engineering. I thought, hey, this is something that I might be interested in. And it doesn't hurt that engineers have competitive starting salaries.
It's definitely a motivating factor to know that, and at the end of the day, you're going to be making a lot of money once you graduate.
Well, I'm going to be moving to Texas and working for a major chemical company, and I was very surprised at my starting salary. It's upper 60s.
I was offered $24 an hour, and I was a little insulted. And I was talking to some kids in a marketing class of mine, and I was like, look at this, like, they don't even think I'm worth anything. I don't even know what this is. And they were like, are you kidding? That's a great offer.
The liberal arts students are just jealous because we're the ones that get jobs when we graduate, and they're still looking.
I mean, the car was supposed to be built this year. We had some troubles making the frame and everything. The mechanical girls can tell you about that, but we always have the hope that it'll be done the next year.
I think I'll probably come back when the car gets built and race it.
I think we would be the only all-female team in any of these races.